In today's video, we have a lot of ground to cover, and so I've chosen to break this up into three different parts, and I'm going to talk about helper functions and free helper functions, as well as friend functions, and I'm going to spend a little bit of time talking about the relationship between classes, because that's something we haven't really discussed too much previously in any of the other videos. So to begin with helper functions, what I want to do is get some of the rules out of the way. And the first rule is that helper functions are external support functions in the form of global functions that contain additional logic for classes. Okay, so these are not functions that are inside of a class definition. For example, these don't reside inside the class definition in your H file. And as we'll see in an example, they actually fall outside of the class H file. They access objects solely through their explicit parameters. And when we look at an example, you'll see how this is actually done. Since helpers are not members of any class, they have no implicit parameters. And free helper. The free helper is a little bit different than your regular helper functions, but a free helper is a function that does not need access to the private members of the class that it supports. And again, this will be much more clear when we get into Visual Studio and look at some examples. And finally, public member functions on the object provide whatever information the helper function requires. Okay, so what that means is the public member functions that we always have in our .h file and then we implement in our CPP file, they provide the information that our helper functions require. So let's go over to Visual Studio and look at some helper function examples. So we're in Visual Studio, and what I want to do is start off with the main function. And I just want to quickly introduce what this particular example demonstrates. So I have two objects here, employee Tom and employee Madeline. And the first number is the employee number, and the second parameter here is the area of the company that they work in, the section. Tom works in section A, and Madeline works in section B. And what I want to do with the logic is just to compare the two objects. So I'm going to call this function rsame. So Tom and Madeline, it's a comparison to see if they're the same object. And if they're the same object, it's going to print out are identical. If they're not the same objects, it will print out are different. So as you can see looking here, Tom and Madeline are not the same objects. So as you'd expect, I would get an output of are different. So let's go over to the H file and see what we have. We have an int for employee number and a character array for section, which section that they work in, because they could overlap and on any particular day work in different sections or be employed in multiple sections. And as you can see, I've got this no argument constructor. I've got a one argument constructor, a two argument constructor, and I've got this display function here, as well as this operator function here. Notice here within my two query functions, they're so small that I'm not actually going to go and do the definition inside my CPP file for this get number and get section. All I'm going to do is just return the employee number and return the section. That's all I'm going to do. And of course, I'm using a pointer to do that. So I'm not going to actually define those inside my CPP. I'm perfectly happy to leave those defined and implemented inside my H file, which is perfectly legal inside of C++. What I want to draw your attention to is this line right here on line 22. This function rsame, and what I'm passing through is a const employee and another const employee. So the implementation to this is right here. I want to read the note. Function not part of the class and is considered to be globally defined. Okay, so if we go back to the H file, what you'll see is that this helper function is actually outside of the class. Okay, so my semicolon terminates the end of the code block for the class employee, and yet I've got this other function on the outside of the actual class definition. So this is what we talk about when we say it's global. So let's return back to CPP, and even though everything is implemented here within the CPP file, what I want you to notice is that this employee, it's the class type with the scope resolution operator, is in the definition of every one of these functions, with the exception of this helper function. Because it's globally defined, we don't need the scope resolution operator to write this function inside this implementation file. So that's something to be aware of. And we're going to talk about this left hand and right hand, but it's a good time if you're looking at this code and wondering what is LHS and what is RHS. We'll talk a little bit more about it in this video, but just be aware right now it stands for left hand side and right hand side. Okay, so in this particular logic, you can see that I'm calling these two get functions. Okay, these accessors. So my left-hand side is calling the get number, and the right-hand side is the get number. And then I'm doing a string compare, which is left-hand side get section and right-hand side get section. And they are, when I evaluate them both to equal 0, this is just a rule. In the end, for this function, when you do it this way, it just means that it's true. Okay? So, in summary, what I have for this particular code is just a comparison to find out if my two objects are the same. Okay? And this is the way I've written it. I've got my function outside of the definition of employee, and I'm implementing this inside the same CPP file, but it is not part of the member functions of employee. So if we return back to this slide, we see that helper functions are external supporting functions in the form of a global function that contains additional logic for the class. So that's what I meant by that. And now that we've seen an example, this should be a little more clear to you. And again, public member functions. So all those functions that were inside the definition of the employee class will provide whatever information the helper function requires. So all those functions will support the global function or our helper function. So there's a cost to this. And free helper functions require queries for information that is otherwise not accessible through existing public member functions. So when we looked at the Visual Studio Code, I mentioned that there were two get functions. Those are our query functions, and those were implemented inside the class. So our function was calling those two queries, which in this particular case is quite beneficial to us. If we need to add a data member to the class, we may also need to add a query to access its value. The class definition grows with the addition of each new query, and we call this growth class bloat. Okay, so as we do this, we end up needing more queries, which makes our class definitions become fatter and fatter, and we don't want to necessarily always have that happen. So there is a way to actually offset this class bloat, and this is by introducing something called a friend. Okay, so to offset this bloat, we introduce friendship. And before I go back to Visual Studio, what I want to do is really quickly talk about just some terminology. And I mentioned that when we were looking at Visual Studio that I would come and talk to you about this left-hand side and right-hand side. So I know this is spaced out a little bit, but what you can see is that int a equals 10. And this is broken up into different parts. So it's important to understand that the int a is referred to as the operand, and the equal sign or whatever is in between your two operands is always referred to as the operator. And then of course you've got the operand again. And sometimes you have one operand with your variables, and sometimes you have two operands when you're trying to initialize them to a specific value. So what this again becomes is left-hand side and right-hand side of the equal sign. So I want to spend a little bit of time talking about helper operators. Okay, so we talked about helper functions. Let's talk about helper operators, because I've kind of introduced this already with the left-hand side and right-hand side. So helper operators are overloaded operators that are global functions. Okay, and we are going to look at an example of this. So candidates for helper operators are those that do not change the value of their operands. Okay, and we'll look at this table below. So the first column here, let me get my laser. The first column here is I've got left-hand operand changes. Okay, it's got either 0 or 1 operand. Okay, and these are the types of operators that it can have. And then your helper operators, neither operand changes. Okay, so the left-hand side and the right-hand side, they don't change. Okay, and that makes it a candidate for a helper operator. And of course, these are all the different operators that we can use. And notice that these operators are not actually the same as the ones above it. Okay, so there's no two that are alike there. So we've briefly looked at this function, this rsame helper function, and there's another thing that we can actually do, and that is to, instead of using that rsame function, we can overload the equals operator to output the exact same result. So let's go over to Visual Studio and look how we can implement that as well. So if we go back to the H file and we look at the two definitions, we've got bool rsame and the rest of the function definition. But if we want to overload that operator, the equals operator, it's simply just a bool operator equals, and everything inside the brackets is the exact same. Okay, so if we go over to the implementation of that, again, we've got the same sort of thing. So this function, not part of the class and is considered to be globally defined, just like the other function, the rsame function. But in this case, we're getting the exact same result by overloading the equals operator. And try to remember what I said earlier about not changing the operands on either side of the operators. Okay, this is a comparison. So when we do this, we, in a sense, we just replace the rsame function. And when we go back to here, it makes no difference inside main, but it does make a difference inside the rest of the code on how we implement this. Okay, so now once I have that done, I don't actually need this code inside of my project file. Okay, I can do everything I need to do with this overloaded operator. Okay, but I am going to actually do my rsame function over in my .cpp file. And when we talked earlier about this, notice here that I'm passing these two objects to employee objects. So in the example, I passed Tom and then I passed Madeline. Okay, and that's where I'm doing the comparison. So let's go to the CPP file and look at that function. And all you're seeing is my left-hand side is calling the get number, and it's comparing it to right-hand side get number. And you notice that either side is actually changing. So this is what we talked about when the operands don't change the values on the left or the right-hand side. the operands are not being changed. They're being compared. Okay, and then again, I'm doing this strcmp. It's just a standard library function, and it's a string compare. Okay, and I'm returning a value, or I'm returning true, basically, by coding my function in this manner. So another thing that I want to do is overload the plus operator. And in this example, what I'm going to do is overload the plus operator to add a single section or employee section to an employee object and return a copy. So the left-hand operand is an employee and the right-hand operand is a char. So let's go over to Visual Studio and see what that looks like as well. Because we have to actually do that in both directions, where the employee number comes first or the section comes first. So we're going to actually look at two methods of doing this. So let's go to Visual Studio. So in our Visual Studio code, what I've done is completely changed out my main function just for the purpose of explaining how to do this, this operator overload with the plus sign. This gives me my employee Tom, and his employee number is 123, and he works in section A. But what I want to do is give him an additional section to work in. So what this will do is it'll print out that Tom works in section A. So what I've done here is I've actually written the other function in case I want to add a new section first. So if you notice an example, line 13, I've got Tom plus B, but on line 16, I've got C plus Tom. So as we look at the code for this, the plus operator overload, you'll see the difference between the two. So simply it just will then again display. So if I go ahead and I run this code, you'll see how it ends up looking. So my code has compiled, but what I do want to highlight is a couple of different issues. So naturally we printed out just the employee object from line 9 and used line 11 to display that. But then I added B after the A, and notice here when it compiled it added it automatically to the right location. But then on line 16 I added the C first to Tom, but it actually went past B, so it stayed in alphabetical order. So let's go look at the code and see what happened there. Before I look at the implementation of this, I want to go and look at the definition of each of these functions. And I also need to highlight the fact that they are outside of the class definition. So up above you have employee, and this is where employee is defined, but these two operator overloads are outside of the class definition, okay, in the same way as this helper function. So this helper operator is actually outside of the class as well. And so what I've done is this operator plus, and I'm passing const employee and the char. So we know that that's going to be Tom, and we're going to add B, and we're going to add A. And in both examples, in the first one I added Tom and then B, and in this second example of this function I added C and then I added Tom. So if we go back to here, this is what I'm talking about. Line 13 and then line 6. Okay, so those two functions are handling either situation. So if I go back to the implementation of this, what I'm doing is I'm passing the object employee, and then I'm passing the section. Okay, so this is just employee copy equals employee. Okay, so I'm creating a new object called employee copy, and then I'm passing in what I pass it. And this makes a shallow copy. Then I'll take copy, do a plus equals on section, and then I just return copy. And so simply on the next version of this operator overload, I'm just doing return employee plus section. And that's giving me the desired result for these two scenarios. Okay? So remember what I said previously about helper functions creating this class bloat. So you notice that I had a couple of query functions, then I had some operator overloading, I had helper functions. So I started to get more bloating inside of my class than I am comfortable with. So that brings up the next part of this, and we're going to talk now about friend functions and what friend functions actually can do for us. So we have to really quickly review encapsulation. So non-member functions should not be able to access an object's private or protected data. Okay, just remember what encapsulation is. So if you're not a member, you don't get in. So let's look at the analogy of having a Costco membership. Okay, if you don't have a Costco membership, yeah, you can get in, but technically you shouldn't be there and you can't buy anything. So think of this in terms of maybe a Costco membership. It's the best analogy I can come up with at the moment. However, there are exceptions, okay, to a Costco membership. So if you have a friend with a membership, that also gets you into the party too. So if you have a friend with a membership card, you can go into Costco and buy stuff under their membership. You're not supposed to, it's against the rules. And just to full disclosure, I'm not advocating that you do this, okay? But I know that it's been done before. So as an example, what if you want a function to operate on two different classes? Okay, so think of a friend function as a function that can bridge two classes. And let's look at this this really quick example. We'll turn it over to Visual Studio in a minute, but let's just look at this for a sec. I've got two classes, alpha and beta. Okay, and inside they have the identical looking data members, which is a type int, and it's valued to 3 and 7 respectively. But inside they've got this int friend function, and it's passing two objects. Let's say the function will take two classes as arguments and operate on their private data. Okay, so what you're seeing in that friend function is that I am actually passing the two classes as arguments. Okay, and we have to use this keyword friend if we want to operate on that private data. So this is our Costco Friends membership. Okay, and what this does is granting friendship pierces encapsulation. Okay, by using that, we pierce through the high security people at the gate at Costco, and we sneak in. I'm joking, of course, because technically you're not supposed to do that. This declaration can be placed anywhere in your class. It doesn't matter if it's public or private. You can use this friend declaration. An object of each class is passed as an argument to the function, friend function. It accesses the private member data of both classes through these arguments. And we are going to look at this in Visual Studio in a minute. So in this program, the two classes are alpha and beta. Their constructors are initialized to alpha equals 3 and beta equals 7. So just one data member each. We want the function, friend function, to have access to both of these private data members. So we make it a friend function. This function definition will look like this. Int friend function alpha A, beta B. And then we just do the math on that, and it turns out to be 3 plus 7 equals 10. In this example, what I've chosen to do is create two classes. So this is class alpha, and down here is class beta. And notice they're both in a CPP file. and down below I've got my main function as well. So all of this code that I've done will be implemented in one location. So let's quickly go through this. I've got a private member variables called int data in both, and I've got my two constructors. So there's a no argument constructor, and it's initialized to 3 for alpha, and it's initialized to 7 for beta. And notice here in both cases I have included the friend function, friend int friend function. That's becoming a mouthful. And I've done that in both locations. They are defined in exactly the same way in both of my class definitions. And then down below, I've implemented the function. So all it is int friend function alpha A, beta B, and I'm returning a calculation. So the sum of 3 plus 7 will come out to 10. That's all this program does. It just adds 3 plus 7 to equal 10. And so I want you to note here that I've implemented this outside of the function. I'm not calling my scope resolution operator or anything like that. And note here that when I actually do implement the friend function, I don't have the keyword friend out front. Okay, it's not required in that implementation. Okay, and so then I'm just outputting the function there. So the key thing to note here is that this friend function that I have does pierce encapsulation. Okay, so that's the important thing to understand, that this friend function has the ability to pierce through the private data members inside of the alpha class and vice versa. So that's why we say that a friend function is actually, it pierces encapsulation. So this is what we mean when we say that we want the function, friend function, to have access to both of these private data members, so we can make it a friend function. This is our entry into Costco. So before we move on, I really want to do a quick recap of the rules of friendship. And it's important to fully understand that friendship grants access to all private members of a class. By granting a helper function friendship status, a class allows that helper function access to any of its private members, data members, or member functions. This is the strongest relationship that a class can have with an outside entity. And a friend of one class may be a friend of another class. And we're going to talk about that again very shortly. And the declaration of a friendship function is the keyword friend, your type, and then your identifier for the rest of your function. Okay, so just to be clear, we've been talking about a friend function. What I want to do is talk a little bit about the costs of friendship. As a rule, we grant friendship judiciously only to helper functions that require both read and write access to the private data members. I know that's a mouthful, but review the video and you need to understand this particular point. Where read-only access is all that a helper function needs, using queries is probably more advisable. Okay, so what we said in the line above is if we've got read and write, that's one situation. But if we have a need for read-only access, then queries are probably a much better option. Friendly classes. We talked about friend functions. Now you need to be aware that there is such a thing as a friend class. So a class can grant access to its private members to all of the member functions of another class. So what we're looking at here is an example of a friend class, and it's actually defined inside of my employee class. Okay, so friend is the keyword, class, the keyword, and then HR hiring. And I have not implemented this class in any other location. This is just as an example. So the HR hiring class can access all information, public and private, held within each employee object. Okay, so this actually lets me access information on every single employee object because it is a friend class inside of the employee class. So in this part, I want to switch gears a little bit and talk about something called reciprocity and transitivity. Friendship is neither reciprocal nor transitive. Not reciprocal. Just because one class is a friend of another class does not mean that the latter is a friend of the former. So let's look at a better example of what this means. So C1 is a friend of C2, but C2 is not a friend of C1. Okay, so we all have people like that. They think we're their best friend, but it turns out we actually don't like them. Not transitive. Just because a class is a friend of another class, and that other class is a friend of yet another class, does not mean that the latter class is a friend of either of them. And that is a horrendous explanation of non-transitive. So let's look at something more simple. C1 is a friend of C2, and C2 is a friend of C3. But C1 is not necessarily a friend of C3. Okay, that's all that means. So in an example, and I'm going to wordsmith this a little bit more, but it'll be less painful. Consider three classes: an employee, an administrator, and an auditor. Let the auditor be a friend of the administrator and the administrator be a friend of the employee. Just because the auditor is a friend of any administrator, the administrator is not necessarily a friend of the auditor. Just because the administrator is a friend of any employee, the employee is not necessarily a friend of the administrator. So this is a lack of reciprocity. And if we look at a lack of transitivity, just because the auditor is a friend of any administrator and the administrator is a friend of any employee, the auditor is not necessarily a friend of any employee. Okay? And now let's start to look a little bit at relationships between classes, because we haven't really spent a lot of time yet talking about this. So in object-oriented program languages, they support different relationships between classes. And so the strongest, if you remember what I said in the beginning, the strongest relationship between classes actually is friendship. So I'm not going to look at an example because I've already done that, but we're going to look at something called composition. So composition, this is a relationship where a class has another class. Okay, so if we look at this example, I've got employee class and I've got the group class. They're just their definition files. And you'll see that the group class has a employee in its definition. You can see there that is an example of composition, where one class has another class inside its definition. And then finally, the weakest is actually an association. An association is a relationship where one class uses another class. Let's look at the association with iostream. To associate our own classes with those of the iostream library classes, we overload the insertion and extraction operators as helper operators. This very tiny little program here, it's just enter a number, you see in the number, and then you entered what it was. So we're looking at the left and the right operands here. So one is an object and one is a fundamental type. So in case you're interested, I just want to go and do a recap of how I coded this employee class. I've got an employee number, a char with a section, and an array of 13 plus the null. I've got a no argument constructor, a one argument constructor, a two argument, a display function, and this operator, plus the get number and a pointer to my get section. And of course they're getters, so typically you literally go out and get, so return what I want you to go and get. Okay, so as easy as that. And you've seen these already, this function here, or the equivalent output version of an operator overload. And then I've got these two here, okay, which are the same exact thing but just in reverse order. And if we start to look at the implementation, here's my no argument constructor, here's my one argument constructor, okay, and I've got the two argument constructor, but notice I didn't put any validation logic in here. It's just very simple. Okay, my display function and my plus equals operator. Okay, that's all I'm doing there. And I'll uncomment that for clarity, but that's my rsame function, which is almost identical to the operator equals equals. Okay, and then this is the implementation of the two other operator functions. Okay, now note that these here four functions, they're all helper functions. They're outside of my class. So when I go back to my H file, notice I've got 1, 2, 3, 4. Okay, and I'm defining them, but make sure that if you're doing this, you don't add this the class with the scope resolution operator. Okay, that's not part of these. These are outside of the scope. They're just implemented and defined in locations outside of the actual classes. Okay. So to recap what we've done today, we've actually looked at helper functions. We've looked at free helpers. We've looked at friend functions, and we touched on the idea of using a friend class. And we very briefly looked at the different relationships. So friend being the strongest, all the way to associations, and in the middle we had compositions. And because we covered a lot of ground, go and do a little bit of independent research and learn more about the helper functions and the friend functions. And the relationships will just naturally come, but definitely do go spend some time on friend functions and helper functions through other resources, and just do a little bit of practice with it. So it's something that is not the most common in the world because of problems or costs that both of them introduce, but there are very appropriate times when they become very helpful. So anyway, thanks for watching the video, and I'll see you next time.